Thank you so much, Dr. Pearl, and thanks for inviting me. Shalom, everybody. I'm just going to take you on my journey here, and of sort of the biodesign process journey, and look forward to any questions at the end if we have time. So let me get this going. So, I've dedicated my life to trying to improve the quality of life of human beings on the planet. That's been a focus of mine, and this is sort of the story of how I've come at this. When I was growing up, and we were thinking about medical innovation, and I learned about it in the textbooks, and even in medical school. It seemed that innovation just happened spontaneously, sometimes by accident. This is the discovery of an inhibited organism on a plate, or an image on a screen from an X-ray. Many of these things were somewhat discovered accidentally, and those discoveries came after lots of study, but often sometimes by accident. And that's what I believed up until I had the opportunity, after graduating from medical school, to take a job at Pfizer, and I met this guy. This is Hank Mckinnon. He was the chief financial officer of Pfizer at the time, and he hired me into Pfizer to work in the devices division, and he gave me a special project. And this is interesting because I often tell my students and fellows that one should really actually believe in luck. Luck actually does happen. It's when preparedness meets opportunity. And that's what happened on this day. He asked me to go find out, why is it that when Pfizer buys these small companies and they become divisions of Pfizer, why they stop innovating successfully. And this was a side project in addition to my regular job, and I was very excited to do it. And his point was that, they seem to be growing very successfully, and then as soon as they get acquired, they stop growing as successfully, and the innovations that they are producing become much more incremental. Why? And these are some of the examples of the companies that were acquired by Pfizer, all of them really incredible innovations, and in a variety of fields. And yet, after being acquired, everything else became somewhat incremental. And what I did is I spoke to all the founders of those companies and their teams, and then I spoke to all the people operating inside the big companies, and the teams that were now running the project. What I realized is that when the founders are on their own, they're just trying to solve a problem, and when they solve it with whatever technology they can find to best fit the problem. But once they become, let's say, a balloon catheter company focused on angioplasty, then they just start looking for other places to place balloon catheters. And they think of themselves as sort of bounded by their technologies, active implants, what have you, orthopedic implants. And so everything is just, where else can we put an implant, rather than how do we solve this next big problem? And so in studying the steps that these founders used, I realized, hey, they first do the need, and then they have some criteria that they want to shoot for, and then they invent, and so on. So I sort of detailed out this process that you see right here. This is sort of the origin of what we now call the biodesign process. And you can see it's quite iterative. These blue lines show that you can go back and retool and improve upon it. And I brought this back to Hank, and he said, that's an interesting idea. So if that's the case, let's try to run the process inside of Pfizer. Go prove that it can work. And we did do that. We called it Fresh Tech, with a PF for Pfizer. And in fact, we were able to show that we can innovate and create a really robust pipeline of ideas and projects just by using that process. And it got better over time. Um, and it was, for the most part, it was very successful. Um, but there were challenges, and the challenges were, in a big company, they just didn't want to take risks. There was a lot of not invented here from one part to the other. So all the big issues inside of the corporation made it difficult for many of these things to proceed, although some did. But I realized at that point that if I really wanted to be an innovator, I needed to leave the big company, and I took this process with me. And so in 1995, I started an incubator called ExploreMed. And the goal was basically to use the process, but this time without the boundary conditions of a big company, and to see whether we could make it work. And this is basically a little bit more detail on how we do it at ExploreMed. It is still the same process, of course. All of this is still the same. But what we did is we said, hey, look, we're going to raise a little bit of money to create this little incubator, and then we're going to go at this and do all this early screening and do this need finding and invention. And then if we can't find things that work, we're going to kill it inside the incubator before they come out as independent companies. And we're going to prove those concepts out. And then once we've proven that it can work in patients, then we'll spin it out as a company. And we believe that this process would allow us to be more successful. And that's sort of what's happened. So just a few examples of the companies that I've founded and been one of the inventors of. Acclarent, which is a really novel way of treating chronic sinusitis. It does happen to use a balloon catheter, even though we didn't know it at the time. We discovered that one can really successfully treat a lot of chronic sinusitis by just widening the passageway in a minimally invasive fashion without extracting all the bones and tissue that is traditional endoscopic surgery does. And so this was a success and purchased by Johnson and Johnson. Another company we created called Neotract is a novel treatment for benign prostatic hypertrophy. And if you're familiar with the field, you know that the most common procedure prior to this technology existing was something called TURP, or transurethral resection of the prostate, which is quite bloody, causes impotence and other problems. And whether you're doing it with a laser or whether you're doing it with a RF probe, or in fact even water, you're going to have so many of the same complications as a result of that. This was a idea of just move it out of the way. It's benign. It doesn't need to be removed. Just move it out of the way. And so we created these little tethers that opened it up. And this is a very successful company, and was acquired by Teleflex a couple of years ago. Another technology that we created, same methodology, again, looking at osteoarthritis, appreciating that there's an early stage form of osteoarthritis, which tends to form on the medial aspect of the knee. And it's really progresses with further weight bearing. So this is like a shock absorber installed right over the knee, and it basically moves those two bones slightly further apart, and it actually fairly instantaneously reduces pain, improves function, and can be quite durable, and it preserves the knee joint. So it's a very interesting alternative for early stage osteoarthritis that is just making its way through clinical trials now. And then one last example, sort of more in the consumer domain, is this, we created the first wearable breast pump for moms. And so if anyone in the audience is familiar with traditional breast pumps, they're noisy, they're difficult to clean, they require disrobing, and it can be very awkward. And this is a pump technology that you can basically wear anywhere, and is quiet and really revolutionary for moms. And we have moms that are explorers, marathon runners, surgeons, nurses, pumping everywhere, and this was the first of its kind. It's a really successful company and growing today. All utilizing the same methodology. And so, over all these years, we've created a number of companies via this. We still are creating companies. We have our latest one that's just spinning out now, called Revel. Many of them successful endpoints. So, we sort of proved that we can do this and use this methodology repeatedly across multiple fields. And in 2000, I met, I had actually known and worked with Dr. Paul Yock for several years before we sat down for this breakfast. But in this particular breakfast, we realized that we could do something really exciting together. Paul was looking to create some sort of educational program at Stanford, which would center device development at Stanford. And we got to talking about the methodology that I created and realized that there could be a great opportunity to transition that into an academic setting and really teach others to do it. And I was really excited by this. My parents were teachers, and sort of teaching's in my blood. And the idea of sharing this and sort of increasing the impact and helping even more people by helping others help people was really compelling to me. So I came on part-time faculty at that time and really put the pieces of the building blocks together for biodesign. And so this is what some of the, I'd say, again, very similar process fundamentally, but more generalized in terms of it's not necessarily only about creating companies. Could be creating an interesting PhD project or a licensable technology, sort of broaden the endpoints to make it more fitting for various academic purposes, but of course could still be used to create companies. And we broke out the steps further to make it more digestible. And this was really the framework for the textbook that we created on the space that's still available. The latest version, I think, is 2.0 or 3.0. And this is sort of a little bit more of the detail of each of these steps of identify, invent, and implement, all along the same lines of this biodesign process. So today, our training program, really the core of it is this year-long fellowship. About 12 fellows come work with us yearly, and then we send them off into the world. There's a graduate course. There's actually multiple courses that have now sprung from that. A series where we interview innovators, and then an international expansion work as well. So we've set up and helped a number of programs across the world set up as well as focusing on executives in companies to try to get even big companies to adopt some of these principles, and it's gone quite well. And that's really, what our mission is. Our mission is to train the next generation of innovators. That's been what we've focused on over the last 20 years. And it's really been a great ride and tremendously successful thus far. So just looking at the results, these are some of the stats of the accomplishments of the programs created. I just say that our goal is not to create companies, but companies do happen. Our goal is really to focus on these individuals and help propel their careers. So we actually want them to fail a lot inside of the program. We don't really actually want them to really focus on creating companies, because might wind up with too much of a singular focus on that. What we want them to do is learn the process so that they can go out and do it again and again. That said, something like 52 companies have been created by our fellows and students over the years. And just those companies alone have touched about 4.4 million lives, which is a really exciting degree of impact. But we really sort of believe that what their greatest inventions, their greatest companies are the ones that they create after the program. So just summarizing, and this process is simple, but it is actually very difficult to do. There are lots of pitfalls along the way. falling in love with your own idea before you've actually validated it is one of them. Having a need that you're going after where you've actually embedded a solution already before you've realized it is another. There's many things like this, but when you can learn it. It does not require genius. It is actually fairly straightforward, and you get better each time you do it. And so, just like any other skill, innovation is a skill that can be learned and it can be taught. And we've proven that after all these years. And so, in conclusion, we really view that this process, which is sort of focused on needs as a primary step in the beginning, is really the DNA of any invention. And the unique appreciation of a need can result in a very unique solution that has never been in existence before, which is sort of an exciting concept. So, if there have been a lot of failed attempts in any historical approach towards any disease state, it could be because they didn't describe the need properly. And once they actually do finally describe it properly and expose that to sort of an iterative process of invention, really can reveal the ultimate solution and one that actually advances the field. And so this rigorous process is something that we really believe in, and obviously has worked for me in my career and the career of many of our students. So I'll just end there and thank you all for listening, and I'm happy to take any questions if there's time.